What if you could delegate an entire software development task, from design to execution, to a team of AI agents? Today, we're going to build exactly that. A multi-agent coding squad using Python and Microsoft's AutoGen library, capable of autonomously developing a simple Python script based on a natural language prompt. This isn't just about single-agent problem solving. It's about orchestrating a symphony of specialized AI intelligences, a product manager, a coder, a tester, and a code reviewer, to collaboratively build, test, and refine software. The core challenge here is managing complex inter-agent communication and feedback loops to ensure a coherent, high-quality output. We'll dive into how to define their roles, set up their communication protocols, and observe them in action as they transform a high-level request into working code. Prepare to witness a new paradigm in automated software development, where AI agents aren't just tools, but active, collaborating team members. Our journey begins by setting the stage for our autonomous development team. The first crucial step is environment setup, ensuring we have AutoGen installed and our OpenAI API keys configured. We'll leverage the power of large language models as the brains for each of our agents, so having access to a capable model like GPT-4 or GPT-3.5 Turbo is essential. Once our environment is ready, we'll start defining the individual agents that will form our squad. Each agent will have a distinct role and purpose, mimicking a real-world software development team. This foundational configuration is vital because it dictates how each agent perceives its responsibilities and interacts with its peers. Think of it like assigning job titles and initial instructions to human team members before they embark on a project. Without clear roles, chaos can ensue, but with them, we pave the way for structured, collaborative problem solving. We'll define a generic assistant agent and a user proxy agent as our starting points, which are fundamental building blocks in AutoGen for creating conversational and interactive workflows. Now, let's bring our specialized agents to life. We'll design 4 distinct roles: a product manager, a coder, a tester, and a code reviewer. The product manager agent will act as the initial interface, taking the user's high-level request and breaking it down into actionable coding tasks. The coder agent, as the name suggests, will be responsible for writing the Python code. The tester agent will then rigorously test the coder's output, looking for bugs and ensuring functionality. Finally, the code reviewer agent will evaluate the code for best practices, readability, and adherence to requirements, providing feedback to the coder for refinements. Each of these agents will be configured as an AutoGen assistant agent, but with carefully crafted system messages that define their persona, objectives, and communication style. This explicit role definition is critical for guiding their behavior and ensuring they operate effectively within the collaborative framework we are building. The nuanced prompts within their system messages will dictate their personality and expertise, making them specialized experts in their respective domains. The magic of a multi-agent system truly shines in its communication protocols. Our agents won't just act in isolation. They'll form a group chat and engage in dynamic, turn-based conversations facilitated by a group chat manager. This manager is crucial. It orchestrates the flow of messages, deciding which agent should speak next based on the ongoing conversation and the task at hand. We'll configure our group chat to include all 4 of our specialized agents and the user proxy. The user proxy agent is our bridge to the human world, allowing us to inject initial prompts and observe the agent's progress. The manager's role isn't just about turn-taking, it's about maintaining coherence, ensuring relevant information is passed between agents, and driving the conversation towards the ultimate goal, a working Python script. We'll define the max round parameter to prevent infinite loops and speaker selection method to control how the next speaker is chosen, which often involves allowing the LLM itself to decide based on context, or a round-robin approach for simpler tasks. This setup enables a natural, iterative development cycle. With our agents defined and their communication hub established, it's time to initiate the development process. We'll start the conversation by sending a high-level software requirement from our user proxy agent to the group chat manager. For instance, we might ask our team to write a Python script that calculates the factorial of a given number and saves it to a file. The product manager agent will likely be the first to respond, interpreting this request and potentially asking clarifying questions or breaking it down into smaller, more manageable subtasks. This initial interaction is a critical step, as it translates a human request into an AI-understandable project plan. The manager ensures that the appropriate agent receives the message and responds, maintaining the flow of the conversation. Observing this initial back and forth gives us insight into how the agents interpret requirements and begin to formulate a strategy, demonstrating their autonomous planning capabilities. It's fascinating to watch them deliberate and refine the problem statement before any code is even written. Once the requirements are sufficiently clarified, the coder agent will spring into action, generating the Python code based on the refined project brief. This is where the core development happens. The coder will write the script, often providing explanations or asking for confirmation. Upon generating the code, it's not immediately considered done. Instead, the group chat manager will likely direct the conversation to the tester agent. The tester will then execute the coder's code within a sandboxed environment which AutoGen handles automatically, analyze its output, and provide feedback. If bugs are found, or if the code doesn't meet the specified criteria, the tester will communicate these issues back to the coder. This iterative feedback loop between the coder and tester is a cornerstone of robust software development, mirroring a real-world agile team, where developers and QAs collaborate closely to fix issues. The agents will continue this cycle until the tester is satisfied with the code's functionality. After the code passes the tester's scrutiny, the group chat manager will then involve the code reviewer agent. The reviewer's role is not about functionality testing, but about code quality, adherence to style guides, efficiency, and maintainability. The reviewer will analyze the Python script for best practices, suggesting improvements like clearer variable names, more efficient algorithms, or better error handling. If the reviewer finds areas for improvement, this feedback is again relayed back to the coder. The coder will then attempt to incorporate these suggestions, leading to another round of potential testing and review. This multi-layered feedback mechanism ensures that the final output is not only functional, but also well-structured and maintainable. It truly mimics a collaborative team environment, where peer review is a vital part of delivering high-quality software, pushing the code beyond just working to being truly production-ready. Once all agents, including the tester and code reviewer, are satisfied with the Python script, the entire process culminates. The final, refined code is presented through the user proxy agent, completing the autonomous development cycle. You'll observe the complete conversation history, seeing how each agent contributed, how feedback loops were closed, and how the initial prompt evolved into a finished product. This entire experience demonstrates the immense power of multi-agent systems, the ability to decompose a complex problem into smaller, specialized tasks, and then orchestrate intelligent agents to collaboratively solve them. This approach has profound implications for the future of software development, offering significant potential for automation, acceleration, and even the creation of novel solutions. You can take this foundation and expand it, building more specialized agents or tackling even more complex projects. So, go forth, experiment, and build your own autonomous development teams. The future of coding is collaborative, and it's increasingly powered by AI.